Good afternoon, everyone. Am I audible? Hello.
आप लोगों को भी अपडेट करना पड़ेगा ना।
हाँ,
तो कल करते हैं फिर इसको।
तो उसमें लिखा है ई ऑफिस के माध्यम सर
ई ऑफिस
आदेश ई ऑफिस के माध्यम से जारी हो
अच्छा जारी होंगे।
जिला
Excuse me, ma'am. Can I post the Google Drive link which contains the notebooks in the chat? Hello. Am I audible?
Hello.
Yeah, sir. Should I post the Google Drive link which contains the collab notebooks in the chat so that students can refer to it while doing the answer?
Yeah, Eswar. Yes.
Yeah, sure.
Yes.
Yeah. Wait a minute.
Yes. You can.
Sure, sir.
Yes.
Should we wait like for 5 more minutes so that?
Yes. We will wait for 5 more minutes
Yeah.
so that more participant can join.
Yeah, sure. Hello, your voice is not clear. Like, hello.
Yes, 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 Eswar, yes.
Sir,
So just
yeah.
just we will wait a couple of more minutes, like
Yeah.
2-3 more minutes, then we will start the session.
I would just like to confirm that if the notebooks are accessible, sir, in the Google Drive. I have given the access. Could anybody please check and let me know?
Yeah, they are accessible.
Yeah. Hello, yeah.
Yeah, hello.
Yes, sir. Shall we start? Shall we start?
Yes, no, just I'm going to introduce you, then you may start it. Okay.
Yeah.
Okay. So very good afternoon, participants. So welcome to the day 14th, uh, second session of today. And today the session will be taken by Mr. Eswar Venkata Kadava. He is a BTech graduate from IIT Hyderabad, who is currently pursuing his MTech in Artificial Intelligence at the Department of AI, IIT Hyderabad. He has recently begun exploring uh, compository in large vision models and vision language models, which broadly falls under explainable AI. So, as a part of his master thesis. So, welcome, Eswar, and session is over to you.
Yeah. Thank you very much. So I am very glad that all of you have joined this hands-on session regarding explainability. I would like to thank my professor Kondareddy sir for giving me this valuable opportunity so that I can interact with bright minds like you. And also I would like to congratulate Triple IT Jabalpur for initiating this summer school so that it can be helpful to a lot of students with this hands-on experience and classes provided by premier institutions. So shall we start, sir?
Yes.
Okay. As conductors are discussed in the morning, so let me briefly give a fresher on what is explainability. So in the last decade, we are we are getting the data which is getting generated is exponential in nature. So the advent of huge amount of data coming, we are able to train it on large deep learning models so that even the performance is also shooting up. So But are we able to inherently explain the performance of the deep learning models is the big question. So that is there something so that we can shed the light on, so their explainability comes to rescue. So can we shed the light on these deep learning models? That's the big question. So yeah, now we are going to discuss about the tools like Lime, which are actually interpretable tools, and we are going to perform hands-on session on various machine learning models as well as deep learning models. Is it fine, sir? So shall we proceed with the opening of?
Yes, yes, yes. You may share your screen.
Yeah, sure. Is my screen visible, sir?
Yes.
Yeah, okay, cool. So yeah, firstly, I would like to let you know all the participants to please download the notebooks which I have already shared in the drive and open it in the Google Colab so that to avoid the compatibility issues. Is it fine with everyone? Can anybody please respond?
I think one more time you may, share the link because some of the participants they joined late. So I think it is not visible to them.
Yeah, sure. Is it fine now?
Yes, yes, yes.
Yeah. I would like to urge everyone to open the notebooks in Google Colab session so that Google servers would run your notebooks and there would be no compatibility issues while installing some of the packages. So shall we start?
Yes, yes.
So yeah. The goal of the first notebook is to display interpretability analysis. The tool which you are going to use now is Lime. Lime stands for local interpretability using model agnostic explanations. The first notebook mainly concentrate on machine learning based black box models. For that, firstly we are going to install the necessary package, which is the interpretable tool, which you are going to use for the most of the session. I'm going to request you please parallelly run along with me so that you can raise any doubts. Please feel free to interrupt me in between if you have any doubts, or you can just pose as a question in the chat. So yeah, getting ready. So this is the command, that is pip install Lime. So to install the interpretable tool, which is Lime. So the single picture clearly explains the what Lime does. So consider a case in have 2D data points, and here circles represent that they belongs to class 1 and the plus signs represent that they belongs to class 0. Suppose let us say we have trained a big deep learning model in this data, and this is the decision which we get. As you can follow along the cursor, this is the decision boundary made by the deep learning model. So it is very difficult to interpret along based on what factors the black box is making that kind of decision. So what we are doing, what the line does is actually you are creating the line stands for local interpretable model agnostic explanations. So L in line stands for local. In the sense, the explanations are going to particular for the one data point. I in the sense interpretable means in the sense here as you can see we are going as said by the sir in the forenoon session also, we are going to create interpretable based boundary like regression using the like using linear regression, logistic regression, etc. Am I is clear? Is this clear until this one? Hello? Hello? Is it okay with everyone until now? Yeah, sure. Actually, what line does this? It creates perturbation along this. This is the data point of our interest. It creates slight perturbations and all and, create all these auxiliary data points for this plus sign. And we are since the deep learning based model, which is black box, is already trained on whole training data. We are going to pass all these data points to the trained deep learning model, and we will get some labels, right? And these data points and that labels would be sent as training data points to the surrogate model which are considering. Here we are actually assuming the surrogate model to be linear in nature. So we are actually creating a linear approximation around the original data point of our interest. And using that, we can create the decision boundary in this fashion. Here you can clearly see that the decision boundary clearly resembles logistic regression classifier, right? So that since this actual plus sign, this is original data point, lies on the left side of the decision boundary. So we can say this is the reason why we can infer it as label 0 or label 1. In this manner, it explains each and every data point simply. This is what the brief primer online. So firstly, these are the libraries which are going to import essentially. We are going to import NumPy. NumPy, as you know, is used for many scientific computation tasks. We are importing matplotlib, which is used for plotting purposes. We are also importing pandas, which is used for creating data frames and working with tabular data with these. And here we are going to import Lime, which I have already installed previously. And from Lime, we are going to import Lime tabular, which is the variant of Lime which is specially designed for tabular kind of data sets. And from this lime.lime test is the we are going to from lime.lime test we are going to import lime test explainer. This is the variant of Lime which is pre-designed for the textual based data set. And we are going to import the scikit-learn. From scikit-learn, we can actually import and train on various machine learning models, and we are going and we also it also contains metrics to compare for deep learning based models. And here for sklearn model selection, we are going to import training test split, which is used for creating train and test data for our black box. From sklearn.naive we are going to import this multinomial NB. This is particularly used for this classification of textual based data, where the training point is actually textual in nature. And then from scikit-learn, we are taking ensemble method from scikit-learn, which is actually pre-designed for importing these ensembling based algorithms like random forest, SGBoost, etc. And then again from scikit-learn, we are importing this metrics, which is used to print various class metrics like accuracy, F1 score, recall, etc. And then from sklearn.pipeline, we are going to import make pipeline. So this make pipeline module is used essentially so that when you pass raw data, so when you pass the raw data on the model to as the arguments to the make pipeline, it actually applies the pre-processing technique as well as apply the model as well as send the mesh apply the machine learning model onto the data. So firstly, we're going to work on tabular data set. So this is the URL which I had used. This is the churn modeling data set. I think you are able to access this CSV file. Are all of you are able to access this? First, let me run through this previous piece of code. I hope everyone is following along with me. If you have any doubt, please feel free to interrupt in between. Yeah. This is the URL which we have. And using the pandas package, we are going to export the CSV to data frame. So yeah, this is the overview of the data set. Yeah. Could you please just wait a minute? So yeah, I hope you are able to view the screen. So this is the overview of the data set. So I'm just printing the first 5 rows of the data set. These are the columns present in the data set, which is row number, customer ID, surname, credit score, geography, gender, and exited. So all the columns except the last columns are the data, and the last column corresponds to label. So actually this churn modeling, what it does is based on this customer ID. So these are the details of all the customers, like where they hail from, like their gender, their age, etc., their estimated salary. And we need to predict how likely they are going to exit based on these attributes, we can say. How like they are going to exit from the bank. So yeah, these are the columns present in the data set: row number, customer ID, surname. So we can clearly see that this surname, geography, gender, these are the categorical attributes, and remaining are the numerical attributes. In the first 3 columns, we can see that this row number, customer ID, and surname are anyways irrelevant, particularly for this class of predicting whether they are going to exit or not, right? Can anybody respond? Like, so yeah, can anybody respond like why these 3 columns are irrelevant? Like why they are not going to influence the last column, whether they are going to exit from the bank or not? You can share it in the chat also. Yeah, perfect. Basically, this row number, although this is numerical attribute, this is completely, this is similar to this serial number, right? That's why it has no role. Similarly, customer ID and surname also has no role, particularly in this decision making where we want to predict whether they are going to exit from bank or not. So we are going to printing all the columns present in the data set. For the purpose of sanity check, we are going to see if there are any null objects are present in the data frame which we have in the data set which we have. So yeah. So yeah. From here we can see that there is no null entry present in the data set. So we can proceed further without any processing as such until this point. Like there is no need to remove any columns, or no need to do any some other pre-processing stuff, or averaging out the remaining attributes and fill in that field, etc. So yeah, So here we are going to create two variables, namely x and y. Here x and y are going to be numpy arrays actually. Here x corresponds to training data points and y corresponding to labels corresponding to the training data points. Here you can see here we are accessing all rows present in the data frame, and we are accessing and here we simply discarding the first three columns, and we are accessing until 13th column. We are actually excluding the 13th column. Here 13th column actually belongs to whether they are going to exit or not. And then similarly for purpose of creating y, we are considering all the possible rows and considering only 13th column, that is their status of whether they are going to exit or not. So here are the first 5 elements present in the data frame. So yeah, this is going to be our training data set to your content, training input data set which we will be having. So yeah, next up we are creating dummy variables. The purpose we are creating dummy variables, let me explain first. Yeah, let me run this and then afterwards I will explain like what is happening actually. Here geography, here the point to note here is we are creating the dummy variables only for this categorical data of our interest, which is geography or gender. So we need to make some sort of processing, right? So that we need to convert them into categorical attributes so that they can be fed directly to the deep learning models, that is black boxes of our choice. Firstly, so yeah, geography or the gender are the one which you are going to select. It is, so yeah, what these two pieces of code is doing is that basically we have three countries actually. If we can see from this data set, we have three possible geographies, which is France, Spain, and Germany. And the gender, we have only male and female as the gender. These are the two columns which are facing the problem as of now, and we need to convert that categorical attributes to numerical attributes. So what we do is we are creating these dummy variables like geography or gender. Now these geography or gender are going to serve as the column names. No, yeah. The reason which are creating this geography and gender is because of the fact that we want to create, since we have three countries in total, so two of them are sufficient. So two of them we want to add as columns to the existing data frame, so that these two are going to sufficient if the field contains what country, whether it is Germany or Spain or the other one, France. Can you explain why is this the case? Like why are we not adding the France corresponding column here? Here we are assigning the Boolean variable false based on whether it's whether that is indeed the geography present corresponding to that row. Can anybody please explain like why are we creating only two geography and only one gender? So yeah, perfect. If Germany is false and Spain is false, then it is obvious that the geography which they are staying is French, right? If Germany is false and Spain is true, then it's obvious that their geography is Spain. If the Germany is true and Spain is false, then it's obvious that their geography is Germany. There is no possibility case of both being true. Why? There is no possibility of both these Boolean values being true. Can you say why? Like, just Yeah, perfect. Each customer is belong to only one geography, right? That's the reason. Similar to this case, we are creating the male attribute column and we are concatenating along the common dimension as you can see. Concatenating along the column dimension as you can see. Here male false corresponds to the female gender and the male true corresponds to male gender only. So yeah. After this, we also remove this geography and gender corresponds to this categorical attributes. As of now, we have only these numerical attributes, and these anyhow can be converted to Boolean attributes, like they can be corresponding to 0 or 1. Yeah. So now we have the data set ready with us. So from this, we're going to split the data set into training data set and testing data set. We are going to the test size which are going to take, which are, yeah, Sangeeta, could you please pose your question? Like, what do you mean by this one hot encoding? Like, one hot encoding in the sense we want inherently they are corresponds false corresponds to 1 0 and true corresponds to 0 only. That model will take care of internally. That's why I have not performed this one hot encoding operation explicitly. Did it clarify your doubt? One hot encoding in the sense converting it into vector only, right? Sparse vector with only one entity corresponding to one. Is it your doubt? Like, does it clarify your doubt? Yeah. So the test size which we have taken is 0.2. So 80% of our data corresponds to training data and the 20% corresponds to testing data. And the random state we are considering is 0. This is just to ensure for reproducibility purposes. So yeah. H-train and H-test contains inputs and Y-train and Y-test contain this labels column, like whether they are going to exit from the bank or not. So since this notebook corresponding to applying the Lyman machine learning models, the first machine learning model which are going to consider is this random forest classifier. Firstly, we are going to create instance of this random forest classifier from this sklearn.ensemble class. So we are creating the object corresponding to random forest classifier model. And then we are going to fit on, and we are using the fit method, and we are passing H-train and Y-train as the arguments. What it inherently does is it trains on the data set and modify the weights. So all this would be performed in this just one operation. Essentially, we are fitting the training data so that we will get the model weights. So yeah, since the model weights are already ready with us as of now, since as we are working with tabular data, we are going to use the special variant of Lime called this Lime tabular. And for this Lime tabular explainer function, these are the arguments which we are passing. So here also we are creating the interpreter object from this Lime tabular class. So we are passing training data, feature names, that is H10 columns, and the mode is set to classification. This is because we are dealing with the classification problem and not this regression problem. The output variable is essentially discrete in nature, right? It corresponds to only 0 and that's why we set the mode to classification. So you might get doubt like, why are we passing the information of this training data to the interpreter? Why not only we need to pass only one test instance, right? Since it's going to create local explanations around that local data point. Can anybody get the doubt? Like, why are we passing the training data also here to the interpreter while creating this interpreter object correspond to line? Juhi, you have some doubt, right? Can you repeat that? I'm not getting you. Like here in why we are only considering 13th column corresponding to index 13, since that is the column which we have labels, right? So yeah. We are also passing the training data because of the fact that this training data is extremely useful while creating the perturbations actually around the test data point, where we need to create the surrogate classifier. This is because whenever this Lime interpreter doesn't have any idea about how the training data appears, it might get surrogate points which are far apart from the test data point, which is not ideal in our case, right? So is it clear? Like why are we passing? It inherently gets the statistics of the training data like mean, variance, etc., so that it can create perturbations accordingly and pass it to the black box model to get the labels, so that this perturbation based data points and the labels we can pass as the input to our surrogate model, which is essentially can be anything like any linear classifier like regression classifier or linear regression classifier or logistic regression classifier, and it can also be this decision tree, which is extremely inherently explainable as said by Sir in the phone session, right? So did you get like why did we pass the training data also? Yeah, sure. Oh yeah, let me know. So for the purpose of our analysis, we are going to consider fifth point in the test data set. So these are the attributes correspond to the fifth data point. So credit score is 670. These are all the attributes. So yeah. So essentially, we are going to create perturbations around this data point, so that we are going to again create all this set of attributes. Like we are going to inbuiltly this random forest, all these models which are there in sklearn creates actually 5,000 perturbations for your information, and that all the 5,000 perturbations are being sent to the black box based model to get the labels, and then we are all going to use this 5,000 points along with these labels as input to the surrogate classifier which we are going to create from the line. So this is the data point. So I am using this just to display like how are the test data look like. This is the data points corresponding to fifth row of the H test data frame. So yeah, here since we have already the interpreter object, we are going to call the method called explain instance. So here are the arguments which are going to pass to the explain instance, which is data row. Here we are essentially passing this test data point of our interest, and we are again going to pass this predict function that is classified.predict proper. How is it useful? Actually, it is useful to, since we are passing the input data point to the model, this classified.predict proper is the function which takes this data point and produce probabilities. Essentially, it performs all the pre-processing and then send to our machine learning black box based model, and then retain the probability. These are the two arguments which are going to pass. So yeah, after passing this, here this is the explanation generated. So to view the explanation in proper format, this is the show in notebook. And I said show table equal to 2 so that we can also visualize the table too. Yeah, let me run through it. Yeah. So as you can see that these are the prediction probabilities given by the machine learning black box based model, that it has assigned 0.81 probability to the class 1 that they will exit, and the 0.19 probability to the class 0 that they will stay intact. But what are the factors which influences this black box's prediction, that we are going to see from these two diagrams. So yeah, here in the first diagram you can see that the so here for the prediction one, as you can see here, this orange labeled features, that is age, whether they are active member or not, male, balance, pain, tenure. So these are the features which are majorly impacting the model's decision for predicting one. Here you can see that there are some features which are labeled blue, which are number of products, Germany, credit score, and estimated salary. So these are the features which are responsible for the model to give at least some probability to the class label 0. So here actually we also got the nice interpretation of, here we get the interpretation on both this linear regression based classifier as well as this decision tree, right? Here, since the age of the person is greater than 44, the number of products is greater than 1. So these are the ones, and the balance as well. Since the balance value is this much, and the balance according to decision tree, since it passes all the criterions of the decision tree, like age should be greater than 44, balance should be greater than this much, tenure should be between 2 and 5, which is expected as tenure is 3 in our case. So we can say that these are the major attributes. These are the major attributes which are present in the table, and their values are majorly responsible for for classifying the instance with label equal to 1. Here you can see that there are also something which with blue bars, which with weights like 0.5, 0.05, 0.2, etc. That is with number of products, Germany credit score. Although there are some, we are giving some weightage to these attributes. These are attributes are not dominant enough to dominate the one level and go beyond this. That's why the model, the the black box machine learning based model using this random forest, that's why it predicted the probability one with probability 0.81, which is obviously greater than 0.19. That's why we can state that the customer is going to exit for this test case. Does anybody have any doubts? Could you share the turn charts? Yeah. Sangeeta, what do you mean by we are not creating perturbations of a single point? Hello, am I audible? We are passing the whole training data because the model inherently knows the statistics of the data, right? So that it can have the better idea on how to create the perturbations in most efficient manner. Right? If we pass that test instance to the Lime interpreter, then it might have no idea on how are the surrounding data points exist around it. If we pass the whole training data, it can get statistics of the data like mean, variance, etc., and can create perturbations accordingly. Did it clarify that out? Yeah. So yeah. So does anybody have doubt on how are anybody not able to understand these diagrams? Like, Actually, we are classifying it as 1 because the prediction probabilities after applying the sigmoid at the last layer is 0.019 and 0.81. You know about the sigmoid function, right? That we will apply during the at the output node of the logistic regression. Since it's binary classification based tasks, that is exit have only labels 0 and 1, right? Since the one label is getting more probability, that's why you are assigning it as class 1. Does it clarify your doubt? Like, we're simply thresholding on a value which is 0.5 in this case. Since the probability corresponding to label 1, which is 0.81, is greater than 0.5, we are assigning the label, we are predicting it as the label 1. What do you mean by summarize the code? Do you want me to explain all? So yeah, sure. I think you have understood till the point, right? Creating the data set and training the classifier, this random forest classifier based on the data set, right? Have you understood till this point? So yeah, basically, once we have this train model ready with us, that is random forest model, and we are able to successfully can predict any decisions once we give the any input data test data instance to it. So here, while we are passing the test data instance, which is, so we're sampling the random test data instance, which is from the fifth row of the test data set, which is this, and we are passing it explain instance. For the explain instance method, we need to pass the two parameters, that is this textual data point as well as the prediction function. So the prediction function, what it does is, it takes this data point as the parameter, and it simply splits the probabilities. It splits the probabilities corresponding to every perturbed data point, so that it can be helpful to create this inherently explainable regression based classifier, right? That's what we want, right? So the explainer is ready until this point. We are simply showing it in the notebook here. For this test instance, 0 is predicted with probability 0.19, 1 is predicted with probability 0.81. This flow is corresponding to the decision tree, which is inherently explainable. So here, this is our actually test instance, which has age value 57, number of rods and 2, like that. Since all these features match this criteria, most of these features match this criteria, that age is greater than 41, is active member is less than or equal to 0. Since the is active member value is 0, this also is satisfied. Male is also satisfied. Balance is also satisfied, as well as tenure. This also is satisfied. So these are the top 5 features. So it is assigning the most weights to it. So since our data point successfully satisfies all these criterions, it also satisfies the criterions corresponding to these also, like number of products value. Number of products is 2, which satisfy this blue bar, which is corresponding to label 0. So these two are actually contradicting factors, right? But since the weights corresponding to label 1 dominates the weights corresponding to 0, we can inherently say that this prediction probability is indeed correct, and we can successfully assign the label as 1 to the data point. Does it clarify your point? Like, is it fine? Yeah, exactly. The model weights are explained in the model. Here, the model weights actually corresponding to model weights like this logistic regression, like linear regression, etc. So, from the logistic regression, which is inherently explainable, right, as told by the sir in the phone session, because in the logistic regression, how the label is associated with features like y equal to theta 1 s1 plus theta 2 s2 plus theta 3 s3, right? Like that, right? So if this, so we are actually predicting these thetas, that is weights. If the weights dominates for the label 1 when compared to label 0, then automatically it would assign, then the automatically our intuition is correct, like why it is assigning label 1, right? What's the weight corresponding to age? Yeah, you can see here, right? But here it actually assigns a weight for both features 1 and feature 0. For the feature 1, it assigns the weight 0.31. Then simply for the feature 0, it would assign the weights minus 0.31 since they are contradicting factors of each other. Here you are taking this case because it's the predominant weight and it is giving most value to 0.31 for the label 1. Is it fine? Yeah. This is the weight corresponding to This is the weight corresponding to age for label 1, and for the label 0 it would simply be minus 0.31, which we have not shown here. Simply since we have only two labels in our hand. I hope that's clear. Yeah, let me show. This method itself inherently creates the perturbations as well as pass it to predict function to get the corresponding labels, as well as train the classifier, like train the classifier which is inherently explainable. Like, are you getting the point? In the same piece of code it happens implicitly. Is it fine? Yeah. So I hope you understood. Working on, as of now, we're working with the modality which is tabular data form, right? So next up we are going to work on raw textual data. But before that, let us going. Shall we take 5 minutes break before that? And I want you to please experiment based on taking other instances like rather than 5 and try how are you getting the predictions. Is it fine? Like, or do you want me to proceed further? I want you to please experiment by taking other data points as well on the same model. Yeah, yeah, fine. And please let me know how are you getting the results too. Like, is it intuitive or not? Like the explanations generated by the decision tree is intuitive or not? That I wanted to know. Mega? What do you mean? Like increase in the value results are more for 0? Like could you be little bit more specific? Like I am not getting it. Prediction probabilities of 0 is. Are you trying with other test data point? Other than the fifth point in the row? Yeah, that's completely fine. Since the Lime explanations are particular to single data point, right? Single data instance, right? So yeah, good. Yeah, it's completely fine. As you can see here, this blue bars contain dominating values like 0.12 and 0.12 here, and this 0.09, which is very minimal for this orange label, right? That's why it intuitively explains that your probabilities which are giving by this black box machine learning model is indeed correct. So are you able to appreciate that? Yeah. Here basically you're getting the prediction probability which you're getting for the class label 0 is 0.7 and for class label 1 is 0.3. So the prediction probability, so the model, so this black box model which is random forest would automatically assign it to label 1. So this is all right. But how can you intuitively know that? So this is the feature and this is the value corresponding to the data point. Like is active member is 1, age is 35. Now these are the ones. So for the blue features, you can see that the bar weights are larger, like 0.12. Like the theta 1 in the theta 1 is 2 plus theta 2 is 2, since this is the relation between the input and the output, right? In the surrogate model, that is the logistic regression model which are going to create for as part of Lime. So since this weights dominates, it automatically assigns more probabilities to 0, right? Since the value. So are you getting it? it Intuitively also it explains that the predictions made by the deep learning model is indeed correct, right? Since these corresponding three blue bars has larger values of magnitudes. Yeah. Just message in the chat so that we can proceed to further modality once you are fine. Once you understand how it's working. on tabular data. So yeah, let's proceed. So yeah, let's proceed further on to the next one. I will take you all your doubts in the upcoming time. So next up, we are going to work on raw textual data. So here we are going to checking the lime interpretable capabilities and binary classification again here. But the input which we are going to give here to the machine learning model is textual data, which is a document. So for that purpose, I'm going to use 20 news groups dataset. The reason why it got the 20 news groups dataset because it contains 20 labels actually. It contains 20 labels like atheism, Christian. So based on the news groups data point here, the data point actually contains document. Here you can see the how input data instance look like from training data. This is the very long test, right? And output simply here is labels from 0 to 19 corresponding to 20 labels. Here each of the label corresponding to categories like atheism, social religion like Christian, like so each of the label corresponding to whether they are talking about whether what is the essence present in the news groups data set. So let's run further. Since we have 20 labels and we're calling it as binary classification here, you may get doubt like why. Here we are considering only these two labels like alt, atheism and social, only these two categories and only extract out those data points which corresponding to these labels. So this news group train contains subset from the training data as well as we are applying the filter which is categories so that we are fetching the only data points corresponding to these categories from atheism and Christianity. Similarly, we are creating test data set and these are the class names like 0 corresponding to atheism and 1 corresponding to Christian. So yeah, here is the training data point for the instance. Here is the of the 0th index, that is the first data point from the row in the training data, and the label for this input test data is atheism. So this newsletter corresponding to atheism. So again, let's further create a data frame so that you would get further visualization on how the test actually looks like and the label corresponding to that test and what is the class name corresponding to that label. Here you can see that these newspaper corresponding to the label 1 which is associated with Christianity. These test is associated with atheism like that. Here for the place constraints we are printing only the first 5 rows from the data frame. So yeah. Here we are using TF-IDF factorizer, which is the purpose of using this TF-IDF factorizer. The TF-IDF factorizer means term frequency inverse document frequency factorizer. So the main purpose behind using this TF-IDF factorizer is that convert each of this, yeah, let me show you. Each of this test to a vector, which is very high dimensional as well as it is sparse. These vectors are generated based on the how frequently they are appear in the vocabulary overall present in the training data. So this TF IDF, wait, let me. So yeah, from this TF IDF factorizer method, we are setting lowercase to false. This is because we want to pass the test as it is. We, we don't want to set the lowercase equal true, which will lowercase all the letters present in the test document corresponding to each data point. So what this vectorizer will do is, the purpose of this, we are instating the object of this vectorizer so that this vectorizer takes all the training input data, which is test, and convert it into vector, that is training vectors. Similarly, for the testing data also, we are also applying the vectorizer dot transform, and the argument which are passing is textual data, so that we are getting training vectors and testing vectors. So if we print the shape of the training vectors, yeah, she's 1079 cross 23035. Here 1079 correspond to number of training points present in the data set, and the 23,035 corresponding to the dimension of the each vector. As I said, right, like this dimension is pretty huge, right? As well as the elements itself are elements present in the vector itself are also too sparse, in the sense most of them would be close to zero, because so many words present which are present in the normal vocabulary might not be present in the test data point, right? So that's why it is sparse vector. So yeah, so again suppose if you want to use random forest for classification, it is usually hard to understand what random forests are doing. Usually what random forest does is, it takes the decisions of the multiple decision trees, aggregate, and then give the final decision, right? For if we have one hollow decision tree, then it's inherently explainable as advice, because we clearly the decision tree clearly have the hierarchy starting from the root level, right? Like if the salary is greater than this, then the label, like we clearly have the filtration category to estimate which data point corresponds to which label. But for the random forest, it is difficult, so we are considering it as a black box, and we need to apply lime on top of it so that it is explainable. So yeah, we are instantiating the object of the random forest classfile, and we are fitting the training vectors as well as train use proofs train dot target, which corresponds to labels correspond to the training vectors. So what this RF fit does is inherently perform the training and stores the weights so that we can use it later for the purpose of inference. Here using the n estimators to be 500. N estimators corresponding to number of decision trees which are responsible for this classification. Oh, yeah, Juhi, please repeat what vector shape signifies. Yeah, just let it. Here training vectors. Here training vectors is actually 2D array. So it contains two dimensions, right? So it's matrix indeed. So 1079 are the number of rows and 23,035 are the number of columns. Here number of rows corresponding to number of data points present in the training data set. So we have 1079 textual documentations which are the input, which are in the training vectors. 23,035 corresponding to the vector dimension which we get after passing this textual document to this TF-IDF vectorizer. So it's pretty huge, right? I hope So did it clarify your doubt? Yeah. So yeah, since we have trained our random forest on this training data, so let's test it on our test vectors. This test vector corresponding to input. This rf dot predict method takes this input test vectors. These test vectors are actually created previously only by passing this all these documents present in the test data to TF-IDF vectorizer, right? So once we pass these test vectors to this predict method, it generates all the predictions. It it generates binary predictions. Why? Because we have already filtered out to have only two labels here, right? Which is Christian and Nazism. So yeah. So yeah. Here actually, Sangeeta, yeah. Here actually, are you able to see my screen? Here actually we'll pass this test document, which is single data point actually. We contain so many data points, but this is the single data point which contains so many tests. This is actually newsletter. It corresponding to single data. Once we pass this to this TF-IDF vectorizer, which we have defined here. This is the vectorizer responsible for taking the textual input and converting it to numerical vector. It does this by a series of operations. If I don't want to explain as of now, as it would take significant amount of time. Is it fine? So 23,035 is the dimension of that vector. So 23,035 elements would be present in the each vector curve. Yeah. Yeah, it's actually similar to bag of words only. It's it's actually some modification of bag of words, I would say. Like what essentially TF-IDF vectorizer would do is it actually also weights each of these words based on how frequently it is appearing in the document of the vocabulary and then assigns the vector based on that. Yeah, it's identical to bag of words only. Is it fine? Shall we move on? Yeah. Yeah. Once we pass all these test vectors, here it is actually in inference mode. Here we are not training this random forest classifier, and this is the F1 score. Here we are passing the labels and we are comparing these predictions with the labels to get the F1 score. F1 score is actually harmonic mean of accuracy and precision. And here we are considering average equal to binary since we have only two labels. Here the F1 score which are getting is 0.92, which is very good because since we are using the random forest classifier, which is very good model, right? Here we are not compromising and we are using the complex model and we are getting this 0.92 as accuracy. And we want to know like what are the factors which are enabling this decision making. What are the factors which explain these decisions? So that for that we are we again want to use the line like why is it indeed so? So firstly we are creating the pipeline. The arguments which are passing to the pipeline is vectorizer and RF. Here vectorizer corresponding to this TF-IDF vectorizer which converts this raw textual data to vectors. This RF corresponding to this trained model, this trained random forest model. This RF.fit would update the weights of the model. So here RF would indeed be the trained black box model. So here this is the pipeline. Here we are making the pipeline because Lime inherently takes this textual data itself. It can't accept these numerical points as the input. So if we have pipeline, we can pass those textual data to this vectorizer so that we will get the vector, and then again we pass this vector to this trained random forest classifier so that we will get the predictions. So these predictions we can generate for the every surrogate data point, and then we can build the classifier on top of it, explainable classifier on top of it. I hope you are getting why we are creating this pipeline. So For the 0th data instance, these are the probabilities which are getting 0.8 corresponding to label 0, which is Atizam, and 0.7 corresponding to Christian. So again, we are creating the explainer object. Here the arguments which are passing is Atizam and Christian for the line test explainer. Here it is another variant of line, which is line test explainer, which is exclusively designed for processing this textual data. That's why you're using the line test explainer in this case. So that we are creating explainer object here. And then we want to generate an explanation with at most 6 features for an arbitrary document in the test set, because only top 6 features would give us more weight when compared to the remaining model. Since those are the top 6 features, those itself will accommodate and significantly impact the model's decision, right? If the weights, so weights of them would be like 0.5, 0.3, 0.2, etc. So this top six weights itself would occupy significant amount of weights, right? So that's why you are taking the at most 6 features for any arbitrary document in the test set. So yeah, for this, since we have explainer object, we are triggering the explain instance method out of it, and the arguments which are passing to it is newsroot test data index, which is 83, which is the 83rd data point in the test set. C dot predict proba. It inherently what it does, since it's pipeline, right? This pipeline passes this data point to the vectorizer and then create a vector. And then since it's a pipeline, it also passes through our black box model, and it spreads probabilities for both zeros and ones. These are the labels. And num features are, since we are interested in top 6 most features. Is it fine? So 83 is the test point instance which we are interested upon. So yeah, this is the document ID. Let me run this. So yeah, these are the probabilities which you get. You might have observed that these probabilities value are changed when compared with the old notebook. This is because this random state, the weights which are initializing at first would be different for this random forest, right? That's why the weights after training would alter by some amount. That's why we we won't observe the significant amount of change here. That we can observe that there is a slight change in probability distribution here that we can observe, I feel. So here true class it predicts achievement because this probability is greater than 0.5, right? This is greater than this. Achievement is greater than probability assigned to achievement is greater than probability assigned to Christian. Yeah. So yeah. So this X variable contain the explanations for this 83rd index instance. So X pair list label 0. What does this indicate? Here label equal to 0. For the label equal to 0, these are the weights with which it comes with for the linear regressor. For the host feature, it is assigning this much amount of weight. For the posting, this much. For the NLTP, this much amount of weight. So you can see that these 6 features are the significant. We are considering only top 6 features, right? That's why only it's printing only top 6 features. In fact, remaining features also would be there, but we are not printing it, and those values also would be so negligible. So yeah. Yeah, sorry for the repetition. Let me do this. Yeah. For the label one, it comes up with these set of weights. What is the observation you can make from these two weights? Can you observe any pattern, any relation between the weights assigned to the surrogate classifier? So yeah, exactly. The weights below are exactly the negatives of the above ones. This is because exactly we have two labels. Suppose these weights are driving the model input towards this label, then these weights must be counterintuitive to this, and they must be negative, so that it should drive to the opposite label, which is the only label other than 0. That's why the both these weights and the signs of both these weights are opposite to each other. I hope you get this. This might not be the case if we have more than 2 labels. Then the way they share the weights might be completely different. I hope you get this. Yeah. Is it fine? So yeah. Moving on, we can see that these two features are significantly impacting the label assigned by the labels making by this black box model, which is 0.14 and this is 0.15. These two exactly contribute to 0.27. So what if we remove these two weights and set this to 0? Will that affect the label? What do you think? Will that affect the label for the as given by the surrogate sample, surrogate class weight? Hello, am I audible?
Yes, sir, you are audible.
So yeah, what if we remove these two? How it will significantly impact the models? What do you think? Like what will it predict? So here actually it should move towards the opposite class, right? If we remove both these and set to 0, then the value will automatically reduce so that it will move towards the opposite class. Since removing these positive ones will contribute to the counter-attacking effort, and so that it moves to the opposite level. That's what we feel, at least intuitively. So let us check if it is indeed the case. So yeah. So this is the original prediction for the label 0. This is 0.54. And we are creating the temp, which is test vectors index.copy, so that we can use this test document. We can store this so that we can compare it after modification. So temp of 0, this corresponding to the data point index, vectorizer.vocabulary posting equal to 0. Essentially what we are doing is, since we can pass only the textual document to the Lime explainer, right? I told you previously it can't take the TF-ID of vectorizer as its input. So what we are doing is, we are simply removing the terms post, host, which are present in the textual data, in the previously mentioned textual data point, and making those count as 0. I hope you get this point. Like after removing these two keywords, which are posting and host, if you are again predict the probabilities for the class level 0, you are getting 0.31. Here the difference is significant, right? Minus 0.54 to 0.31, the difference is minus 0.23. Here here it alters the decision too, right? Here in this case, the label which the model assigned would be 0.54. In this case, the model assigned by the black box, the label assigned by the black box model is essentially 1, right? Since the probability assigned to the label 0 is 0.31, which is lesser than 0.05, 0.5. Sorry. I hope you get it. Like how important are these words how important are these words post, host, etc. in explaining the model's decision, like random forest decision. I hope you are able to appreciate that. So yeah, if you are visualizing the explanations, yeah, these are the ones for the class autism. like host, posting, NNTP, edu, etc. These are making a significant. These are making. These are playing a significant role in making it look like class autism. Similarly, for the class Christian, it is these weights are exactly opposite to the tough class autism weights, which you can see here. So yeah. Here actually these two these two diagrams are also analogous to the previously mentioned bar plots. Here also we are simply plotting the weights as in this orange, like how for assigning the Christian class host, these are all playing significant role, and how for assigning autism, these are playing the significant role. So yeah, let's visualize the original document, like how that affect the classifier most. So yeah, so basically the black box model, it assigns the probability of 0.54 to autism and 0.46 to Christian. So here we can see that see from our lime tool that these are the words which are making significant impact in the model's decision of assigning the probabilities like this to that particular data instance, like edu, NNTP, posting, host. These are the ones which get significant chunk of weights, right? So we are highlighting these steps. The thing which we can observe here is this edu, NNTP, posting, host, etc. are actually belongs to something like subject of the news report or the header of the news report, right? I hope you are seeing this, right? This is not part of the subject, right? Subject which they are trying to convey, right? Can anybody please clarify? Like,
Yes, sir. Yes, sir.
so yeah. So this is how using the line tool we can bring out something which we cannot trivially see from the deep learning based black box based model. So yeah, that is the that is why you need to appreciate the usage of these lime tools for local explainability. Here also you can see that the edu is in footer, right? Post is actually is only in one place in the subject actually. So yeah. So most likely the test we are going to assign is autism, right? Since the every newsletter might contain edu, NNTP posting, etc., the significant chunk of the points in the data set would be assigned the autism. That's what we can infer using the line. Okay. Okay. Why the weights for the Christian class would be negative of the autism class? This is because intuitively you can see that, right? If the one set of weights are positively impact in the one class, then the set of weights must oppositely affect the other class, right? That's why we need to assign the negative sign to it. If there are more than two class labels, then that won't be the case. If one prediction pushes the label towards 0, then the negative of that should automatically steers that towards the other label, right? Intuitively speaking. Since it reduces the value significantly. Does it clarify your doubt? Like, why would get the weights in that fashion? Yeah. Let's proceed further. In the previous instance, we have applied the filter that we are going to consider for the only two classes. Here, now we are going to consider the case for multi-class classification. But how can? What do you mean by how can we interpret what is host? Host, these and all are actually the words present votes present in the textual document in the each data point. Since the weights assigned to those votes are more, we can say that the presence of votes, those presence of votes are significantly impacting the model's decision. Does it clarify your doubt? At least to an extent. So yeah, let's move on. Here we're not going to apply the filter and we're going to train our classifier on the multi-class classification. So we are going to have more than 2 labels in this case. That is 20, all those 20 labels. So yeah, here we are renaming some of the class names so that those are easy to read. Like we are removing the unnecessary things and retaining the part which is and retaining the only part which is readable and easy to understand by us. So yeah, join in the class and these are all essentially 20 class names. Autism, graphics, MS window, these are the ones. In the previous instance, we consider only those classes, autism and is Christian, but here in this case we are going to consider all the classes. In this case also we are repeating the same procedure. Again, we are going to pass all this to TF-IDF vectorizer and creating train vectors and test vectors out of it. Wait a second. Yeah. This time we are going to use not random forest but multinomial naive Bayes for classification. What does this multinomial naive Bayes means? Does anyone have any idea? Lowercase equal to false. By default, lowercase is set to true, which will make the test to lowercase before passing to the TF-IDF vectorizer, which we does not want, as the important details might be lost during the pre-processing. That's why we set the lowercase to false explicitly for our case. Does it clarify? Here we are going to use multinomial naive Bayes for classification. This can be used for multi-class classification. Yeah, cool. When we have more than 2 labels, here alpha equal to we are setting to 0.01. Here alpha refers to smoothing constraint. Here alpha equal to 0.01 signifies that we are going to actually this multinomial naive Bayes works. So you might have idea regarding this Bayes algorithm, right? Bayes decision. By probability of assigning a particular label given the class instance. Based on that, this is actually some hyperparameter you can feel, since it would take so much time. So here instantiating the object of the multinomial naive Bayes classifier, and then we are fitting the training vectors as well as our label vector, that is target vectors. So now we have the trained weights ready. So this is the F1 score which we got, which is decent enough, right? Since we have only 2 labels in the previous case, we got so much F1 score, but here 0.83 is also reasonably good enough when compared to the simple models like logistic regression, which might not give these good amount of accuracy. So now we want to explain this, how to make the explanations using Lime for this multinomial naive Bayes based black box. So yeah, again we are creating the pipeline. We are passing the vectorizer as well as the trained naive Bayes. We are taking the first 0th index data point from the test data set, and we are rounding the decimal places to 3. So here's the predicted probabilities. We can see that we are predicted 20 probabilities here, one corresponding to each label. Is it right? I hope you got it. So yeah, for the line test explainer, we're inserting the object. Here line test explainer we are using, since it is actually again the textual data, and the class names which we are passing. Here now the class names vary from 0 to 20 in our class from all the 20 labels. So yeah, here now the interested testing instance which we want to take is 1340. So we want to explain that instance. For that, we are passing this test data point as well as this function responsible for assigning the labels to each and every data point. Num feature we are again setting it to 6. Labels which are considering only for 0 to 17. The reason we are considering for labels only 0 to 17 is because we want explanations for only these two labels, like how it is assigns probabilities to only two labels. At first, we want to see this. So yeah. Predicted class, we can see the Achidam, and true class is from newsproof test.target, we can get the true class, which is also Achidam. So yeah. Here are the weights which we got for Achidam as well as the explanation for the class mid-east. The 17 corresponding to the label corresponding to this class name mid-east. So this is how here we can see that the weights are not actually negatives of each other, right? Since we have multiple labels present. So for the purpose of Achidam, these are the weights. Here also we are considering top 6 weights, which is from cause to certainty. For the class mid-east, these are the factors which are significantly explained in the prediction for the class mid-east probability. Yeah. For this, if we want to predict probabilities, this is how for this test index 1340, this is how we get the probabilities. So alternatively, you can ask the line for the top k classes corresponding to higher probability. Here, this one and this one has high probabilities, right? No, this one and this one has high probabilities. So we can ask the line to generate explanations for only those two labels also. Line can generate explanation for all the labels. So we can ask the line inherently to generate explanation for only these two labels. So top labels is set to 2. You can see that. So these are the available labels. 0 and 15, which is indeed correct, right? Since these two have highest top two probabilities. So yeah, let's see the visualizations for these top two predicted labels. So yeah, top two predicted labels are Achidam and Christian, which is also indeed the case in our previous case also, right? We have chosen only Achidam and Christian. But so yeah, these are the weights, these are the factors which significantly push the models toward this Achidam, this diagram corresponding to Achidam and this diagram corresponding to Christian. Like why it is predicting the label Christian with 0.43 probability, this diagram explains. Why it's predicting the Achidam with prediction probability 0.5, this diagram explains. Like cause, drive, genocide, these are the factors which significantly affected for the model to drive towards Achidam. And these are the factors like cause, genocide, FSU. These are the factors which significantly impacted for the model to drive towards Christian. Here we can see that both are nearly equal to each other. That's why we can see that there is shared features among the Achidam and Christian as well. I hope you get this intuitively. So yeah, let's generate the explanation for the top one predicted label. Here the top one predicted label is Achidam, as you can see. If we generate only the label for the top one predicted label, which is Achidam, we set a labels equal to 0 means that the class name corresponding to highest probability. The 0 indicates that, which is Achidam anyways in our case. So here are the tests with highlighted words like owlnet, genocide, cause, rise. Like these are the words which significantly make an impact in model decision making on it to Achidam. I hope you get something until this point. Do you have any doubts as of now? As of now, we discussed the impact of Lime on these machine learning models on modalities like textual data. Yeah. So yeah, Explaining predictions from line briefly. Should I explain with the tabular data set? Like that would be easier for you to understand, I guess. For the multinomial case. So yeah. For the multinomial pipe case, for the multinomial case also we are passing these two are the arguments to the pipeline. That is vectorizer, which is responsible for converting these two vectors, the textual documents, and this NB, which is the trained naive-based classifier. So C dot predict proba newsrep tester data 0 round 3 indicates it passes the first data point to the predict proba function and predicts 20 probabilities according to this. Here explainer, line test explainers. Here we are creating the object based on this. Here we are taking this variant because line test explainer because it is particular to this textual case, which is clear, I feel, right? Since it is pertaining to the documents which are sending as the input to the model. So class names equal to class names. Yeah, class names here in this case are all 20 labels. So from this explain for the method explain instance, we are passing these as the parameters. So let us analyze what are these parameters. Newsgroups test dot data of index. Here we are actually passing the textual data corresponding to this index. Textual document corresponding to this index. C dot predict proba. This actually takes this as argument and predict probabilities for it. Has inherently it converts it into a vector and pass this to the ML model and then calculate the probabilities, which is response. This is the so we are passing it as function to argument. Num features we are setting it to 6. So that we want to only see the here features corresponding to words in this case. Just like column names corresponding to column name corresponding to features in the tabular data set. Here words actually corresponding to features. So we want to see only the top 6 words which are significantly impacting the model's decision. Labels as usual are from 0 to 17. So yeah, we're printing the documented ID, predicted class and true class. I hope you here X contains explanations. Let's now we want to somehow visualize the explanation from this exp variable. So we are passing it. We are passing the argument as label equal to 0. Here 0 corresponds to what? Corresponds to what? Class 0, right? Which is autism. So, hello. Yeah. So we are only getting weights for the only the top 6 words which are responsible for classes which for assigning it as Christian label for that particular data point. Similarly, for the we are assigning label equal to 17, that is for Middle East. In this case, these are the words which make significant impact for assigning the label equal to 17. Here we need to consider both the labels. Line can generate explanation for all the labels. Here we are containing labels from 0 to 19, that is for all the 20 classes. It can assign the generate the explanations that is weights for every label. The way this drives the models ultimately decides which would get the greater weight and that we would assign as the predicted label in this case. I hope you get it. Here the top 2 labels equal to 2 in the sense we are interested on the explanations on the only those labels which contain the top 2 highest probabilities, which are indeed atheism and Christian in our case, so that we are visualizing the weights for only these things. I hope you got it. Yeah. So let's move on to next notebook. I think we have very lesser amount of time, so that I would like to cover it with little bit quickly, I hope. I'll take the doubts at last. So since now I have covered about machine learning based black box models, right? Generating explanations for, now we are going to generate explanations for deep learning based black box models. So yeah, firstly, we are going to generate explanations for one of the pre-trained ImageNet models. Pre-trained ImageNet models, what it does is it takes the image as the input and it directly predicts the probabilities for each of the classes. I think you are aware with CNN, right? This ImageNet is one of the pre-trained CNN. I hope you guys know it. So let's quickly install the dependencies. Lime, which is the interpretable tool of our interest. Yeah. So these are the essential libraries. Chasing a self-explanatory. These torch vision, torch.autograd, etc. are the variables, are the libraries which are essential for the PyTorch initialization. Like PyTorch was one of the essential packages for important packages for image-based dataset. So yeah, we are going to import all of this. From Torch Vision contain the image-based datasets. From this, we can also import models. From models only, we can import this pre-trained ImageNet models. From transforms, we can make the transforms on our raw image so that it is compatible to be passed to the pre-trained ImageNet model. From Torch, here we importing Torch.autograd because we want to calculate we want to backprop, which we will discuss later when it comes. From torch.ln.function level, this is used to create neural network. I think you know this. Yeah. So from the URL, we are writing the function to get the image, to get the RGB image. So yeah. So this is the image of our interest. We want to consider to be given as input to the pre-trained model. So yeah. So now we want to apply the transformations onto the image. So we consider the get input transform function. What it does is transform.normalize with mean as this and standard deviation as this. What it does is for the first channel, it does x minus mu by sigma, which is h is the corresponding pixel intensity minus 0.485 divided by sigma. So that every channel, so that each channel would be Gaussian with this mean and with this standard deviation. So this normalization essentially helps us for the model to, so that all images lying on the same training distribution, so that the images won't get out of training distribution. I hope you know. It is also part of the batch normalization, right? That's why we're pre-processing the image like that. So this is what this normalized variable do. This transform that compose. So we first resize the image to 256 cross 256 dimension, and we want to center crop it to 224. That means we want to consider only the 224 cross 224 image from this resize 256 cross 256, starting with hinge at the center, and then we want to transform this image can be considered as array, right? Three-dimensional array. RGB can be considered as image can be considered as three-dimensional array. We want to transform that to tensor, so that it can be passed to PyTorch easily. So since the PyTorch usually accepts the input in terms of tensor, that's the reason we are doing. That's the reason for defining this transform function. So get input tensor image. Once we pass the raw image, we apply the transform on top of it. And since this is the single image and we want to append the batch dimension to, that's why you perform this dot unscale.0 so that it can be directly passed to the deep learning model. The single image, we are adding a wrapper around it with the batch of dimension 1. I hope you are getting it. Can anybody please confirm quickly? Here next we are instantiating the pre-trained model, which is inception v3. Here we are setting pre-trained equal to 2 so that we do not need to train the model again, and we can directly pass the, actually no reasons as such. We just want to, this image can be seen as test instance which can be passed to the live model. That's the reason. Essentially, if we pass this to black box deep learning model, we will get some predictions, right? With this test data instance, that I mean these image only, we want to check its explainability capabilities too. No, right? Live explanations are for only single instance at a time. That's why it's local, particular to single instance. Here, multiple images are not required because we are passing it to pre-trained model, so no training is necessary, right? It will directly take the image as input and predicts the and outputs the probability classes of the labels. I hope you get it. You can try out, you can experiment on different images you like and see how it generates on the same notebook. Yeah, once this session is. Is it fine, Rajesh? Yeah. Next, we want to label tests for ImageNet programs. So we know that what model is predicting. So yeah, actually, this JSON file contains. Yeah, it's all in the same setting. Yeah, you can use any image you want, but make sure you do this necessary transform step before passing it to the model. So yeah, this JSON actually contains. This JSON is actually the form of dictionary, right? It actually contains the labels as keys, and it actually contains keys as labels and with values as the class names actually. So it actually contains this very big dictionary, and it actually contains 1,000 elements with each key corresponding to each label and each value corresponding to each class name. So that we are fetching that JSON, and for the class index, we are doing it this way. We are loading the JSON, and we are constructing this index to label, class to label, the class to label, and class to index. These are the dictionaries. What it essentially takes, what this class to label does is it takes the class name as input and then spits the label. What class to index does is this is the dictionary which contains keys as class names and labels as the labels as the indices. Yeah, these are actually essentially to map the labels to class names. That's what. Yeah. Since so yeah, since we have already since it's already a pre-trained model, we have the weights ready. So image get input tensors image to get the image tensors, and we set the model in evaluation mode so that no parameters gets updated, and we're predicting the logits based on this. We're directly passing the image as parameter to the model to generate logits. From these logits, we can apply the softmax on top of it to generate probabilities. I hope you got it. And we are visualizing the only top 10 probabilities, and we can see that it's actually a huge dictionary. Like we have around 1,000 labels, but we are seeing the probabilities for only the top 10 labels for visualization purposes. These are the labels which predominantly dominates the predictions. Yeah. So now you have that dog instance ready as well as the deep learning model pre-trained ready. So that we need to use the lime on top of it. So this is the fill transform again. This is the pre-process transform. This is actually replicate to the previous function which I have used, but we are using it separately so that transforms the reason. Wait, let me be. Here we are defining two functions, namely get pre-transform and get pre-process transform, because this get pre-process transform is applied to the lime images which are sending, but both these processes together define the how we should send the image as input to the black box model. For sending the input, for sending the image as input to the black box model, both these transforms should be applied. But for sending the input to the surrogate model, which we want to line model, which we want to make the explanations, we can, it is essential. This pre-process transform is enough. So yeah. Get batch predicted images. So it takes the set of images, which is batch of images, and in it produces probabilities for all of it, which is the highest, like what is the label which you can assign. Like, I hope you are getting it. I'm sorry, I'm going a bit quickly. Let's test our function for the sample image. Yeah. We are passing our image on to the batch predict function after applying the pill transform on top of it. And this is the index. And from index to label dictionary, if we pass the index, you can see that it is predicting that it is Bernoulli's mountain index. But what is the explanation that why this model is giving Bernoulli's mountain dog as the label, which we want to see from using this lime explanation. So yeah, this lime image is the variant which particularly uses for the image type based data set. So yeah, so we're instantiating the explainer class. From this, we are triggering the method explain instance. For this, we are passing the as this is analogous to previous cases only, right? Here we are passing the input test instance, which is the pill transformed image. Since here also we need to pass the image as the input only. The drawback with line based interpretability models is that it won't simply accept tensors. We need to somehow send the image in raw format only. Since here pill transform only, this is before actually this pill transform preserves the images, right? It doesn't convert it into tensor. Only after applying get this pre-process transform, it converts to tensor. That's why we only apply pill transform and then passed it as test instance to our line based explainer. So this batch predict what it does is it takes this image, creates a tensor out of it, pass to the pre-trained model and generate predictions out of it. Top labels equal to 5. Here we want to concentrate on only top 5 labels. Explanation for only top 5 labels generated for the model with highest probabilities. Num samples equal to 0. Here 1000 refers to the perturbation samples which we are going to consider. Yeah, it's running. Before running itself, let me show how the output look like. As you can see, you might run it on your notebook and cross check it if once the session got over. From scikit-learn.segmentation, we are importing mark boundaries so that it can aids us to draw boundaries like this. Temp.mask equal to explanation get image and mask. For you want to get explanations for this top labels only 0, like top labels of 0, which means it gives probability for all the labels, right? This explanation that get image actually gives prediction for all the labels, but we want to consider only the label with the highest probability. Positive only equal to true. Positive only equal to true in the sense we are only going to consider those set of images which have positive impact, those regions of the image which have positive impact on the explanation, positive impact on the prediction. Num features equal to 5. Num features are actually the image regions actually. Yes. And num features is basically num features equal to 5 in the sense we are dividing this whole image into 5 significant portions. And we are only going to mark boundaries on only the image feature which is of most importance to us. So yeah, this is the image boundary we want to mark, and plt.times from image one. Firstly, we are plotting the image. On the top of it, we are creating the boundary out of it based on this criteria. Like mark boundaries, this temp would give the pixel locations where it's of primary importance to us. Like we can see that for that image, the model is seeing this dog image inherently for generating that explanation. That's what we can say intuitively. I hope you get the at least intuition behind it, right? Can anybody respond? Yeah.
Yes, sir.
Can I take 10 minutes of your time? Is it possible? Like,
Yes, sir, you can.
so yeah. Since we have already generated the lime explanations on pre-trained dataset, now we want to visualize the prediction generated by the CNN model trained from scratch using the MNST dataset. Before, only one image is sufficient since it's already pre-trained model, but we need to train the model from scratch. So the dataset which we are using is MNST dataset, which contains digits, grayscale digits. Yeah. For this, you are using TensorFlow. You are just pip installing it. So yeah, these are the libraries. So this Keras is analogous to neural net layers of PyTorch. Here, Keras is simply a wrapper around the TensorFlow. From that, we can import layers as well as import MNST dataset too. So yeah. We're downloading the data, splitting it to train and test data, and doing necessary pre-processing. And then we are converting to 2D images to 3-dimensional RGB images, so that this is because of the fact that our deep learning model only accepts this. Even our lime only accepts in this format, so that for it to be compatible, we are converting to RGB. So we're instantiating CNN object. So this is the shape of the input image. We are going to take 16 filters, which each the channel dimension should be 3. So this input channel shape should match with each other. On top of that, we are applying the ReLU activation. Once it is done, we are applying math spooling 2D. I hope you know this, how to do math spooling, like taking 4 pixels at once and clubbing it to single pixel, like maximum pixel out of it. And once we got the feature map, and then we want to flatten it into single vector, and then create a layers dot dense with the 10 as output layers, and then we want to, this is the MLP part, we are flattening and passed it to MLP, and this is the output dimension which you are considering as 10 since we contain only 10 MNST digits. So yeah, we are setting the optimizer to be Adam. This is the loss we are considering cross entropy since we have 10 labels. Once we are model fitting, after running this one, we will get the trained model right now. Trained CNN. I'm not running it since we are out of time. I just want to explain what's happening inherently. So now we have the trained model ready. Now we want to generate explanations on top of it using the install line in the same fashion as above we have done. Here also similarly, we are passing the 10th data point of our train. We are reshaping it, pre-processing it, and then positive only equal to 2. We are concentrating on the only those regions which positively impacts the explanation, and where hydrest equal false, like hydrest equal false in the sense we want to remove the remaining pixels, but here we are not removing the all these pixels, right, which are not responsible for explanation. So yeah, this is how these are the regions of the image which are responsible for predicting three MNST digits. So similarly, we can check it out for remaining test instances also, and then running the surrogate model on top of it. For 2, we are getting this. This is the mask we are getting for the 2. So these are the regions which are significantly impacting for the model to be predicting 2 as the label. So yeah, similarly, For the 9, we can see these are the regions which are significantly impacting. Similarly, for the 4, these are the outer boundary regions which are significantly impacting its 4. So what we can infer from it, these edges and curves are playing significant role for the model in deciding which label it needs to assign. So that's what we can learn from this line explanations. So what we can infer from here is these edges play a significant role for any CNN model in determining what digit is it. I hope you get the intuition right. Hello, am I audible?
Yes, sir, you are audible.
Yeah, like these vertical strokes, curves, and edges are very crucial for this black box model in determining which digit is it. So yeah, and then another interpretability technique I want to show to all of you, which is grad cam, which is, does SAR cover this in the morning session?
Yes, sir.
Here actually grad cam refers to gradient based class activation map. Someone said no, like Priham, Sangeet. This is simply another interpretable technique similar to LIME, but what it also generates local explanations. But the way it creates the heat maps is in this fashion, like from the label. So the model assigns the probabilities for all the labels, right? It picks the node with the highest probability. From there on, it backprops through all the activation layers in between. There will be activation layers for the CNN, right, which we have mentioned previously for the CNN model. It simply calculates those class activations, and then it while during the back propagation, which it assigns heat maps based on the values of the gradients it got for all the class activation maps. So let us say during the first class activation map, if the pixel in the one cross one field gets the highest value, then those we will assign with the. So we can say that pixel is most responsible for the classification. That's what we can say. Simply based on the gradient weights which are getting during back propagation, we overlay heat maps based on that. For that, we are using the line image. I hope you will get through all of this. Like upsample, this is simply for overlaying the image. This is for computing heat map. This is the main function similar to line for grad cams. This is the simpler version of grad cams, I would say. So yeah, this is the original image and this is the heat map we can get, so that we can say that these facial regions is of, so red regions corresponding to the values with highest intensities. So we can say that these facial features are the mostly responsible for the model to classify it as a line, and then remaining features like this, like legs, etc., are of not that importance. I hope you get the intuition right. Like, what does this signify? What does this heat map signify? I just keep it as a aside. Actually, I just wanted to cover it. Yeah. This is also the one of the important technique only, particularly related to images other than line. The drawbacks of the line is that it explains the only locally, that is for the particular instance only. It fails to capture the global explanations of the model, right? So yeah. Though there are so many models which can explain the global explanations like the Shapley values, etc., which you can refer that. Yeah, that's what I would say. Suggest to all. I hope you get at least some intuition by this hands-on session. If you have any doubts, you can ping me. I have even shared the. I have even shared my contact number to Supriya ma'am, I feel, in the mail. Oh yeah. Oh yes, sir. Am I audible? Do you still have any doubts? If you have any doubts, you can ping me anytime. I will also share. Yeah.
Sir, if you don't mind, can you share your mail ID? Someone is asking in the chat. If possible.
Yeah. Sure.
Yes.
Do you want me to share this institute mail ID or? I'm sharing my institute.
Yes, sir, it's okay. And
Yeah.
and thank you so much. I think if you have any doubts, participants can post to that mail. And thank you
Yeah.
so much, sir, for your valuable time and giving us a wonderful hands-on experiences on this. And
Yeah.
thank you so much once
I'm
again,
sorry
sir.
that I might be a bit rusty.
Yes, sir. Yes, sir. But okay, you have given a valuable information, sir.
Yeah. At least you get some intuition, I feel like, from.
Yes, sir. Yes.
Once you go through the notebooks, you will only understand.
Yes, sir. We got it. We got it.
Yeah.
Yeah.
So yeah.
Okay, sir.
Yeah. Thank you. I would like to thank you once again for making me through this session, for patiently bearing me. Yeah.
Yes, sir. Thank you. Thank you, sir.
Yeah. Thank you. Can I leave now?
Yes, sir. You may leave. And the participants, thank you for attending this section. Hope you have a very good, wonderful day from morning and now also. Thank you so much.